Hello everybody, my name is Zaid Almusaied. I'm a PhD student at Texas State University, Department of Material Science, Engineering and Commercialization. Today I will talk about my research where I made a hybrid surface of hydrophilic superhydrophobic nature for fog harvesting. Water is one of the most essential substances for life on our globe. Our body consists of about 60% of water. We need water in every aspect of our life. And with the continuous growth and population, mostly we have water shortage crisis happening, and it's expected to increase during the future. And while our globe is covered, about 71% of it is covered with water, only 1% of it is fresh usable water. So the solution for water crisis can be seen through using untapped sustainable resources, such as the water on the atmosphere, where we have about 3,000 cubic mile of water on it. Some of the water on the atmosphere is already condensed, like fog, and there are many creatures in nature that generate their own water, either from the gaseous form or from the liquid form or the fog. One of the most famous creature that is generates its own water is the Stannicura beetle. This beetle inspired a lot of research to create a lot of surfaces, especially hybrid surfaces for fog harvesting. Now, my hypothesis for this research is that I can make a hybrid surface using a new method of additive manufacturing, spray coating, and mixing casting of a composite. Also, that water collection rate can be enhanced when I have a hybrid surface in compared to non-treated surfaces. Then the ratio or the dimension of the hydrophilic region and the pitches between those regions are going to influence the water collection rate. The method, I made 8 samples, so 6 samples were hybrid surface with 2 different diameter and 3 pitches between them. And then there are 2 samples. One is non-coated, so it will be hydrophilic, and the other is super hydrophobic only. And I compared them. My method is to create the hydrophilic region separately from the super hydrophobic region and then attach them together to have the hybrid surface. So how I did that, I designed using Inventor sheets, thin sheet, about 100 micron in thickness, and I made holes in them. So I'm trying to create an array of those holes, 4 by 4, and I have the diameter varying from 400 to 500 with 3 different pitches for each diameter. I printed using a 3D printer or a PolyJet printer. Here you can see the CAD design for my sheets, and I add L-shaped frame around them so that they are not going to warp. And the last design on the bottom, you can see it doesn't have any holes, so this is just to have either hydrophilic or just super hydrophobic. After printing my sheet, I cleaned them manually, and after cleaning with sonication also, I try to make sure that there is no support material from the printing on my sheet, also by using solvent. I use acetone, methanol, and isopropanol to clean my sample. Coating those samples, because those samples after printing are hydrophilic, and I'm here making the super hydrophobic region. So I attach those sheets into a glass, and then I made an apparatus where it consists of a controlled stage, stepper motor, Arduino, and I control the speed of the movement of the stage, and I use airbrush to coat my sample. Of course, I made my super hydrophobic coating using fumed silica and ethanol. Now, preparing the hydrophilic region is through making a composite. For the composite, it consists of resin and a hardener. The resin is bisphenol base and hardener is diamine, and 50% is is the mixing. So 1-1 is the mixing of those, the hardener and resin. Then I mix 75% filler, which is copper powder, into my polymer, which is 25% only. I made mold and I put all the mix together and mix them for 3 minutes, manual with the spatula, level for 1 minute. Then finally I attach the sheet, the coated sheet, to the composite, which is the composite, of course, is a hydrophilic. And of course, you can see that there is an extra part. That part I clip it before testing my sample. Now, the experiment setting, I use a humidifier, commercial available humidifier, to emulate the fog. I made a holder for my sample, and I attached my sample to the holder. The distance was 12.5 centimeters from the head of the humidifier. I put a Petri dish to collect the water. Each run was 1 hour, and I weighed the water after that. Of course, also I measured the flow rate of the mist coming from the humidifier. And you can see on the picture how the growth can be controlled on the hydrophilic mostly of the sample. Now the results, I divide my result into 3 parts. One is dimension, and one is wettability, and finally the water collection rate for the samples. So I measured the diameters and the pitches of the sheet after printing, and I found that the diameter was always smaller than my intended design. So I end up changing the CAD file for each diameter, increase it by 200. So I have the original design, modified design, then the overall fabricated sample, which is the gray bars here, where I have the diameter for those. And on this slide, you can see the pitches. Also, I measured the pitches are better, so it's controlled more than the holes. The printer couldn't do the intended hole as I want. Here I compare the design and the fabricated, and the difference between the ratios of the pitch to the diameter of the fabricated to the design is between 1 to 10, except for the 400 diameter and a pitch of 600. Here it was about 27 to 28%. Now, for the thickness of the layers, I use optical microscope, digital microscopes, and for the coating, the 4-layer coatings, I put a tape and coat it, then remove tape, create a step, and thus measure the thickness. Here you can see the thickness of sheet without any coating, and finally measure of the composite part of the sample. The next step is measuring the wettability of the component. So I measured the advancing receding contact angle for the hydrophilic sheet and the hydrophilic composite and the super hydrophobic coated sheet. I created a quasi-static condition for the measurement. And you can see for the super hydrophobic coated that I have a really small hysteresis, which indicate that I have a Casey Baxter condition. So it was really super hydrophobic, and droplet, as soon as you put it, it will move away. Finally, the most important result, which is the water collection rate. As I said, I collected for each sample the water collection for about 1 hour per sample, and the highest water collection rate achieved for the 500A3 with 1600 micron pitch, and the second one is the 562 and with 1062 pitch. Now, the mechanism and why this collection is happening in this particular way, where hybrid are achieving higher water collection rate, can be explained with the 3 rough stages, where we have first capturing the droplet, and second is migrating and accumulation of those droplets, and finally shedding. For the migration accumulation on the hybrid is better because the force that drives the droplet to move from the superhydrophobic into the hydrophilic is shown in equation 1. So the difference between those surface energies and thus the contact angle between the two make the droplet move over there, and then they will grow until their size will make them have a stronger gravity effect on them, so than the capillary pinning force that will attach them to the surface, and shedding will happen. In conclusion, the hypothesis is fulfilled through the making a hybrid surface, and that hybrid surface was making more water than non-treated surfaces and the superhydrophobic. And I can show that one of the samples and one of the ratio was giving 57% more water than the non-treated one. Changing the dimension of the diameter and the pitches was changing or influencing the water collection rate. The method that I introduced with this research can be scalable, and the surfaces can be attached to any curvature of the surface, so it can have any shape that we want. The method of 3D printing can be replaced with any other method where it is more affordable, and maybe the accuracy can be higher for the dimension also. Further studies are needed for studying the influence of factor on the fog harvesting and the relation of those factors.